Hello. Today I want to show you how to use some of these recently discovered double and half angle formulas. If you haven't seen how those were derived, I would suggest that you ask me or refer back to the videos that we've made. But I want to use them to answer an extremely common question I've seen in a lot of books and quizzes and tests in college, and even I think on ACTs and SATs occasionally, and that is that usually you can be given one piece of information. In this case, we're told what cosine of theta is equal to, and we're told this vague idea of about where theta is, and usually then you're asked to find some other value for maybe theta or maybe even some other angle. For instance, maybe you're asked to find, okay, what's tangent of theta? Or you're given this and you're asked, what's sine of 2 theta? Anyway, you can answer all these different questions by doing kind of the same step, and so we're going to do that. We're going to fill out a chart and find all sorts of information about theta and 2 theta and half theta and so forth. And in order to do that, the first thing you'll need to do is to usually take the information you're given and find other values for that particular angle. In our case, we know what cosine of theta is. We're going to figure out what sine of theta is and tangent of theta is. And the most useful tool for that is some variation of the Pythagorean theorem, maybe the Pythagorean identities, but we'll need to draw a triangle, see what we can get from there. Once we know that angle, then we can use the double angle formulas with our current angles values, and we can determine all sorts of things like what sine of 2 theta is and cosine of 2 theta and so on. Or we could use our half angle formulas. If we use our half angle formulas, the half angle formulas have plus or minuses in them. They're not really strong enough formulas to determine whether our answers should be positive or negative, and so then we're definitely going to need to think a little bit more about what quadrant the half angle is in. But that's a useful skill to do. Anyway, so here let's look and see what we can discover about theta and what some of its other values are. So first thing I want to do is just sketch a picture for where theta is, what quadrant theta is in, and use that to figure out whether sines and tangents and cosecants and all those sort of things, whether they are positive or negative. So they told us in this case that theta was an angle between 180 and 270 degrees. And so if I sketch a picture of that somewhere in here, I don't know exactly where, but that's certainly a quadrant 3 angle. And I can tell you quadrant 3 angles, whether their sines are positive or negative, whether their tangents are positive or negative, and so on. The sine tends to be connected with a height, and so this is below the x-axis, and so sine is going to have a negative value. The cosine is often referred to as the x-coordinate, or the horizontal part of this. That's definitely to the left of the y-axis, which would be a negative value. In fact, our given was negative 3/5, and so we can fill that in. Tangents, I like to think of tangents as the slopes, and this slope is definitely positively sloped, so it will be positive. Another way of determining the sign of tangent is tangents are sines divided by cosines, and sine is negative and cosine is negative, and so the tangent will have to be a positive. Negative divided by a negative is positive. And then the cosecants and secants and cotangents, those are the reciprocals of the original, and so they're going to have the same sign. A cosecant is going to be the reciprocal of sine, and so it'll have the same negative sign that sine had. Secant is the reciprocal of cosine, and so it will also have a negative value. In fact, I can fill that in right now. The cosine is 3/5. Secant's the reciprocal of that. That would be 5/3. And the cotangent is certainly going to be a positive value because tangent was, and it's the reciprocal of tangent. But how do we get the numbers for sine and tangent and cosecant and cotangent? To do that, we need to draw in a triangle. And I have seen two different approaches to this. One is to use the unit circle. And so if I make this a unit circle, then the value that was told to me is the horizontal, the negative 3/5. And if this is a unit circle, then the radius of this is 1. And if I expand that triangle just a little bit so we can see it more clearly, it's 3/5 out, and it's some unknown height down, and it has a radius of 1. And so I could use the Pythagorean theorem on this particular triangle, and that would allow me to figure out what this blue segment is, and that blue segment is sine. And so I can solve this 3/5 squared plus the unknown sine value squared equals 1 squared. And after a little bit of arithmetic, we can figure out that x is either a positive or a negative 4/5. And we've already figured out earlier that because this is below the x-axis, it has to be a negative 4/5. So that's a fairly common technique, is to draw a triangle and use the Pythagorean theorem to figure out whatever piece or pieces you don't know. A variation on this, which I've seen, which might be even easier because you don't have the fractions to deal with, is to go back to SOHCAHTOA and realize, all right, cosine is adjacent over hypotenuse. And so let's draw a triangle. And here, I'm not even going to worry about what quadrant this is or anything like that. I've got an angle adjacent to that angle. That would be this side. And hypotenuse to that angle would be over here. And then I can use the Pythagorean theorem to figure out what the third side is. Or I could recognize this is a 3, 4, 5 triangle. And that saves a lot of time if you identify this is a Pythagorean triple. And now that I know all sides of this triangle, I can find sine of theta, tangent of theta by using the SOHCAHTOA acronym again. Sine is opposite over hypotenuse, and so sine of theta would be 4/5. You do need to realize that it could be a positive 4/5 or a negative 4/5, depending on what quadrant theta is in. Tangent is then opposite over adjacent, so opposite would be 4, adjacent would be 3, and so again, might be positive or negative 4/3, depending on what quadrant theta actually is in. And so, again, some people do that because then they don't have to deal with fractions. Doesn't matter. Somehow we need to figure out what all those different values are. So we figured out tangent's 4/3 over here. We could also have figured out the tangent was 4/3 once we knew what sine was. Sine divided by cosine is tangent, and when they both have the same denominator, fifths on top of fifths, the fifths cancel out, and 4/3 is the tangent value. And as soon as you know sine, cosine, and or tangent, you can reciprocate those to find cosecant and cotangent. The cosecant value would be the reciprocal of sine, which would be 5/4. And the cotangent value would be the reciprocal of tangent, which would be 3/4. So, knowing one piece about theta, the cosine in our original problem, allowed us to find all the other 6 pieces of theta that we were interested in.